College Algebra, Chapter 1, Section 5, Solving Inequalities. Objective 1. Use interval notation. Roster notation is when you list all the elements that you want. Perhaps they're solution set, but it's usually a small enough list that it's only a few elements. If you've got a very, very large and infinite list, then we have two other methods, interval notation and set builder notation. So I'd like to show you both of those because we're going to need to use those. The textbook does use interval notation, but it really doesn't bring up set builder notation very often, if at all. So this is interval notation on this side. And set builder notation on this side. So in the center, we're going to have all of our graphs. Let's see, a closed interval is one where both endpoints are solid. Our book sometimes uses a square bracket like the interval notation does. An open is when you've got A and B with two open circles, but all the points in between. Half open, half closed. Gosh, spell it right. Closed is when either one side is kind of solid and the other is an open circle. You can switch the sides here. Could be closed at A and open at B. Then you've got things that go to infinity, perhaps to the right, perhaps to the left. Those circles could also be open or closed. If this is B and this is a closed and go to the left, goes to negative infinity. Usually put a arrow at the end, an arrow at the end here too. So, what does interval notation look like? Well, closed, when you include the endpoint, you use a square bracket. Open, when you exclude the endpoints, you use parentheses. Got to be a little careful here. It looks like an ordered pair point to plot in a plane. You have to have the interpretation because it's being used for intervals for answers or something like that, that they would know it's set notation. When the left side is open, you use a parenthesis, and the right side closed. Of course, it could be the other way. It could be a square bracket on the left and a parenthesis on the right, but you'd have to have the open circle on the right also. Here's an open circle, A, and then you go up to positive infinity. For infinities, you never use a square bracket because you can never get to infinity, even though Buzz Lightyear says you can. If you have negative infinity, you'll never get there. So this goes from a negative infinity up to B, and in this case you include the B. So square bracket includes the endpoint, parenthesis excludes the endpoint. What about set builder notation? All of these sort of start out the same way. The set of all x such that. Now it could be y, it could be z, but some variable or a combination so you know what it looks like. This is just, in our case, these are just x's or they could be y's. And then for each of these, you need an interval using less than, greater than, these inequalities. For this one, it is A less than or equal to X less than or equal to B. That's because A is greater than or equal to A, but also less than or equal to B. Here you got A, but now it's strictly less than because it's not equal to, also less than B because it's not equal to, ended with this brace. Half open, either A is less than X is less than or equal to B, or vice versa. The B could be less than and the A less than or equal to. Here, X is greater than A, and here, X is less than B. You could say B is greater than X if you wanted to read it the other way, but usually they put the variable first. So these are the notations that we will be using along with graphing for all of these points. For the graphs, our textbook will use, instead of the dots, solid and open, we'll use a square bracket and a square bracket for the closed circles, and an open bracket and an open bracket for the open circles. I sort of like the circles, but this does mimic that set builder notation. So maybe it's good. Next screen. Now, objective 2. Use the properties of inequalities. Now we're going to sort of write these sort of formal. There's one called the non-negative, which says for all A elements of the reals, that upside down capital A is for all A, and then this C with the line in the middle is an element of, and of course this is the symbol for the real numbers. A squared is greater than or equal to 0. You can never get a negative number when you square it, because two negatives make a positive, right? So, what about the addition properties of inequalities? The add prop of inequalities. Now we had the addition property of equalities, which meant you could add the same thing to both sides, and the equals would remain the same. What we're going to do for this one is, when you add or subtract, the inequality symbol remains the same. And in order to get all those, you need to write a bunch of stuff here. If A is less than B, then you can add C to both sides, A plus C and B plus C, and the inequality symbol will remain the same. If A is greater than B, then this would be greater than. It'll remain the same if you add C to both sides. Now, if A is less than B, and you subtract A minus C or C from both sides, B minus C, it still remains the same. So addition or subtraction does not change the direction of the inequality sign. Then there's the multiplication property of equality, or inequalities. For this, if you multiply or divide both sides by the same negative number, then it will change the direction. But it won't if it's positive. So if A is less than B and C is greater than 0, then AC is less than BC. It doesn't change. And for greater than, if C is greater than 0, then it remains greater than. But if A is less than B and C is negative, less than 0, then the inequality sign reverses. AC is greater than BC when it was less than over here. And if it's greater than and C is negative, then AC is less than. It switches the direction. So only when you multiply or divide by a negative do you change the direction of the inequality. This works for less than or equal to also. Greater than or equal to also. Next we have some reciprocal properties. Of inequalities. Now you're going to say, well, a lot of this stuff's just remaining the same. Why do we need to say this? It's important to make sure you understand that it will remain the same. Multiplying or dividing by a negative changes the direction, but everything else seems to be okay. So if A is positive, greater than 0, then its reciprocal is also 1 over A is also positive. If A is negative, then 1 over A is negative. Now one way to write this as one thing instead of two of these is an if and only if statement. A is greater than 0 if and only if 1 over A is greater than 0. Because we could have this the converse also being true. If 1 over A is greater than 0, then A is greater than 0. Doesn't matter which one you put here. So you can write this as a if and only if statement. If A is less than 0, if and only if, not if A. A is less than 0, if and only if 1 over A is less than 0. The whole thing to notice is nothing changes the direction of the inequality unless you multiply or divide by a negative. What are combined? Well, we need objective 4 here first. Solve combined inequalities. Okay, what is a combined inequality? It's when you use and or have a continuous inequality. In other words, if x is greater than 2 or x is less than a negative 2. Now on the number line, here's 0, here's 2, here's negative 2. What we're saying here, the reason we need an or, if this is what we want, of course, is that greater than 2 is an open circle into the right. Less than a negative 2 is an open circle into the left. So we've got two different inequalities that we're combining with this or. We need the or in this case because we couldn't use and. They're not both greater than 2 and less than negative 2. No answers would work with that. Suppose we want x is less than 2 and x is greater than a negative 2. This is where we would need and. Of course, we want to make sure this is our situation, but this is all the stuff in between because it's greater than a negative 2 and less than 2 at the same time. In this case, we can use a continuous inequality. Negative 2 is less than x is less than 2, which looks more like the number line than it does for over here. This one looks like the number line 2 when you split it up. I think that's a good way to think of it. This and you can replace with this continuous inequality. So, suppose we look at the problems on page 132. Examples. Number 16. I'm going to ask a little bit different question. You're going to be given a number line with a graph, and then you're supposed to write it in interval notation, and I'm going to say write it also in set builder notation. They just want you to write an inequality, but might as well use it in set builder. So here's the number line. They say here's a -1, here's 0, and here's 1. So they want you to start here and go up to here. Now they're using the parentheses and the square bracket. I guess I prefer the open circle and the closed circle. But they also want everything in between. Means the same thing. How do you write this in interval? Well, this method really shows you. We have a parenthesis, a -1, comma 1, square bracket. In set builder, and the reason I'm asking this is because besides you say the set of all x such that, they want you to write this inequality. So this is a -1 is less than x is less than or equal to 1. So all they wanted in the book was this part. But might as well practice set builder notation. Don't have to add much more. Number 30. Write an interval notation and graph it. So they gave us x greater than 1. If this were set builder notation, set of all x such that x is greater than 1. So you don't have to add much to get the set builder notation. I'm going to graph it first. If x is greater than 1, here's 0, here's 1. You don't need to put a bunch of dots on here. Greater than is not equal to and to the right. That's an arrow. For writing this with interval notation, it's a parenthesis because you don't include the 1, and you go up to infinity, and you never include the infinity. So, writing in interval notation, set builder was given, so to speak. Next screen, number 38. Now you want to write it in set builder and graph. Let's see, they give us the interval notation, parenthesis, -8, infinity, and I think a graph is easier to work from. So here's the -8. They want you to start there, but don't include it, and go to infinity, which is to the right. Interval notation would be, oh, they already gave that. Set builder notation would be the set of all x such that x is greater than -8. Did these make sense? How about number 50? Here we want to supply the correct thing. This is where you're going to say, I can't get 4 steps. But first of all, write the instructions. Fill in the blank, right? With less than, greater than, less than or equal to, greater than or equal to. They said the correct inequality symbol. So that's one step. Then they would give us if 3x is less than or equal to 12. Then x blank 4. You're supposed to fill in the blank with that. Well, we just have to take the 3x less than or equal to 12 and divide by a positive. When we divide by a positive, the direction of the inequality does not change. And so x is less than or equal to 4. We should put less than or equal to in the blank. So you can get 4 steps. Not hard at all. Number 70. Next page. Here we're supposed to solve each inequality and express your answer using set notation or interval notation, and then graph it. So we're going to get some steps here. Number 70. 4 is less than or equal to 2x plus 2. Is less than or equal to 10. So how do you solve these continuous inequalities? Well, really it's two inequalities. This 2x plus 2 is greater than or equal to 4, and 2x plus 2 is less than or equal to 10. But you can just focus on the middle, and if you can get that down to an x, then you've solved it. I'm going to subtract 2 from all three sides. Then I get a 2 is less than or equal to 2x is less than or equal to 8. Then I'm going to divide, focusing on the middle, everybody by 2, because that'll get me to my x. 1 is less than or equal to x is less than or equal to 4. So now I've got this in set builder notation, the set of all x such that in interval notation, it's, well, let's graph it. Here's 1 and here's 4. You want or equal to and or equal to, and x is between. So square bracket 1 comma 4 square bracket. So solve it and write it all three ways. Graph it, set builder notation, interval notation. Let's do one more at least. Number 88. Zero less than 3x plus 6 to the negative 1. Put that in parentheses. To the negative 1 is less than 1/3. Okay, let's see here. So the first thing I need to do is take care of this negative 1. It's really the reciprocal. 1 over 3x plus 6 is less than 1/3. Now what's nice is when you take the reciprocal, if you think about this as the number line, say this is 0 and this is 1/3, if you switch the direction of the inequalities here, flip this over, just get 3x plus 6. Because all of this is greater than 0. Remember, that was one of the things. If this is greater than 0, then we can keep this direction the same. So taking the reciprocal, but say, oh, the reciprocal of 0 is 0? Let's think about this for a second. And then you can go to 3. So if I'm over here from 0 to 1/3, and I take the reciprocal, because we're not equal to 0, we can just write this and not change the direction. Now we subtract 6 from all three sides. So negative 6 is less than 3x is less than negative 3. Divide everybody by 3. And a negative 2 is less than x is less than negative 1. This would be the set of all x such that that continuous inequality is true. For the graph, we've got a -2 and a -1, open circle and everything in between. And therefore it's parenthesis, -2, comma, -1, parenthesis. You should be able to do these. We'll see you in the next section.